this last example that we have is a bit more unique compared to the other examples. So let's start off just by doing the questions. So one, we need to ensure that the equation is in turning point form, so let's complete the square for this. So this becomes y equals x squared minus 4x plus 2 brackets squared minus 2 brackets squared plus 7. So this becomes y equals x minus 2 squared minus 4 plus 7, and so therefore your turning point form is y equals x minus 2 squared plus 3. So from here, let's look at the next part. What is the nature of this point? The nature of this point, it has a positive a value, so therefore the parabola will be positive, U-shape. And if we have a look at the turning point in this case is just the flip sign, so that becomes positive. So positive 2, 3. So the turning point will be at 2, 3, which is equal to the turning point. From here, what we need to do is we need to then eventually find the Y-intercept. So to find the Y-intercept, we step 3, I'll do it on this side. Step 3, we let y equals 0. So step 3, sorry, x equals 0. So we let x equal 0. And if we let x equal 0, what we end up getting is y equals 0 minus 2 squared plus 3. Y equals minus 2 squared plus 3. And so from here, what we end up getting is y equals 4 plus 3. Therefore, y is equal to 7. So therefore, the y-intercept is at 0, 7. That's the second point that we have. Now we just need to find the x-intercepts. So step 4, x-intercepts, let y equal 0. So from here we get 0 equals x minus 2 squared plus 3. This next case that we're going to come across is very unique in the sense that we haven't looked at this in the previous videos. So if we try to rearrange this 3, this ends up becoming x minus 2 squared equals minus 3. Let's just look at the next step. So what we would usually have done is go square root of 3, or minus 3, sorry, is equal to x minus 2 squared. However, the idea that you might have come across that you need to take the square root doesn't actually apply to negative numbers in this case. So whenever we have a negative number, we actually can't find the real solutions to it. So if we're ever asked to find the square root of a negative number, this usually concludes the case that there is no real solutions. If you eventually take more advanced maths, you'll find out that the square root of 3 does come up with another value. But for now, we just understand that if we have to take a square root of a negative number, it usually means that there's no real solutions. In other words, no x-intercepts. So we'll need to be quite wary of this, because the next step tells us to plot the relevant points and join. So what points do we actually plot them in this case? Let's have a look. So let's just plot what we've got so far. We've got the turning point, which is this. So let's plot 2, 3 on the graph. So 2, 3 would go right there. And then we have 0, 7. So it's 0, 7 that goes up there. And from here, we don't actually have any further points. So what we're going to do is we're going to join up this point right here, and we'll see how things go eventually. So you can see that, I'm just going to redraw this one. that the line ends up going like that. But where's the third point going to be? What we need to actually implement is something called the axis of symmetry. So with parabolas, the axis of symmetry for this particular case goes down this way. So the axis of symmetry is going down this way, which means that everything on the other side of this line should be exactly the same thing. So I'm going to draw this in red, and you can see that if we go 2 across this way, it means that when we go 2 across the other way, we should come up with exactly the same value. So I'm going to join that line now, just so you can see that we come up with the axis of symmetry in this case. So if you don't come up with alternative points, what you can do is then, if you have the turning point, implement the axis of symmetry so that you can continue to find the third point. So if I was going to say to you, this is your parabola right here, so this is the turning point, and it goes up this way, and that's the other point that you're trying to find. To find the axis of symmetry, all you need to do is just imagine where's a symmetrical line, and the line will be, or the point will be, plot somewhere around here, so we can just continue to say that that's how the parabola would look. So the domain in this case, if we just finish off the question, domain, okay, what are the possible x values that we could have if we enlarge the graph? Again, like all the other questions, minus infinity to infinity because there's no restrictions on it. And the range, what are the possible values for y? So what's the smallest value it can be? It can be 3. It can equal 3, but it goes up to infinity. So in this case, we have to infinity.